Hello, welcome to this video. For your information, this video is going to discuss about Chapter 6 Chemical Equilibrium, which is on the calculation question. Generally, we divide the calculation question into 5 main types. Reminder again, in this video, we are not going to discuss the working step, but we are going to focus on how to identify which type of calculation needed to carry out. Let's start with the first type of calculation. Substitute the concentration of pressure into Kc or Kp expression directly. But make sure the concentration of pressure is at equilibrium condition. Now, let's look at the first example here. Kc is given. At the same time, concentration, nitrogen and ammonia also given. So we have to check, is this concentration given is at equilibrium? Yes, it is. So means that you can directly use Kc expression and then determine the concentration of hydrogen at equilibrium. So, Kc value given, concentration NH3 given, concentration nitrogen given. So you only have one unknown here. So you can solve this problem. Okay, now let's continue with the second type of question, at where Kc will be given and then you are looking for the new Kc. So, how the question will look like? Let's check. Kc is given for this following reaction. Then the question asks us to look for Kc for the following chemical reaction. These three chemical equations look quite similar with this one, but actually they are different. What's the difference? They can differ from coefficient. For example, the first here has 1 mole of hydrogen, react with 1 mole of iodine, produce 2 mole of hydrogen iodide. But for question 1, the coefficient become 2, 2, 4. Another type is the reactant and the product change their role. So look at this second chemical equation. We notice hydrogen and iodine initially is act as reactant, but now they are product. While for the hydrogen iodide, which are product, but then now it's become the reactant. So third type of the question, they will combine these two. Different coefficient, and then the position for the reactant and product also different. So this is the second type of calculation question. Are you looking forward to the third type of calculation? Hope so. So in the third type of calculation, you need to remember this formula. Kp equal to Kc RT delta N. Do keep in mind that R is referred to gas constant. The value that we always use is 0.08206 liter ATM per mole per Kelvin. So make sure the pressure is always in unit of ATM, volume is in unit of liter, and then the temperature will be in unit of Kelvin. Now, how you know that you need to use this formula to solve the problem? Kp is given, and then the question will ask you to look for Kc, or Kc given, and then question asks you to calculate Kp. Let's look at the example here. If Kp for this reaction is given, and then determine the Kc. So this third type is the easiest one for me. How about you? Now let's continue with the fourth type of calculation question. Generally, the fourth type will ask us to compare the Q reaction quotient with the K equilibrium constant. So how are we going to know we are going to use this method to solve? Generally, these are the characteristics of the questions. Number of mole or pressure or concentration of all the substance are given. All the substance here means all the reactants and also all the products. Okay. Second, the question will ask you, is the system at equilibrium? And then what is the direction? So let's look at this. Check. The first criteria, Hi, hydrogen, iodine. All substances in the chemical equation are given. Is the system at equilibrium? This is the second type. Which direction? This is the third criteria. So if the question have these three criteria, basically you are going to compare Q with K. Yes, we are at the final type of calculation at where we are going to use ice table. So this ice table is not made up from H2O, but is made up from initial, change, and equilibrium. So, as usual, we need to know what is the characteristic from the question that we can know. We need to use ice table. Generally, initial number of mole, concentration or pressure will be given. Sometimes, maybe they will give us about degree of dissociation, or they ask us to look for degree of dissociation, or they ask us to calculate the Kc value. But then we notice that the concentration or the number of mole or the pressure given is not at equilibrium. For these three cases, we are going to use ice table. Let's look at the first question, first example. At a certain temperature, the equilibrium constant is given for this chemical reaction. If 2 mole of NO2 is placed, so is placed at here we'll consider is initially, because it's like we just put into the container, so which refer to initial, and let the reaction to occur. So if you already put the NO2 into the container, so the reaction will happen. Only have NO2, NO2 will become N2O4. So calculate the concentration of NO2 and N2O4 at equilibrium. If you look at here, this question have the criteria of number 3 here. They ask us to calculate the concentration at equilibrium. But from the question here, we didn't have any information about equilibrium. That means that we have to use ice table. Now, look at the second example. Sulfonyl chloride is a very reactive gas. It decomposes follows the equation. Given the initial pressure is 0.078 atmosphere, so when we are given the initial pressure, maybe we already have the idea that we need to use ice table. But then we still try to continue to read the question to confirm, is it ice table? Is possible. When the system attains equilibrium, the total pressure is 1.43. So here just give you a reminder. The total, from the word total, we know the mathematical operation is addition. So what are the gases will be at equilibrium? Sulfonyl chloride is available. Sulfur dioxide also available. Chlorine also available. So means that we have to add on the partial pressure for these three gases will be equal to P total. So P total or total pressure is different from Kp. If we want to write Kp for this chemical equation is Kp equal to partial pressure sulfur dioxide multiply with partial pressure chlorine divide with the partial pressure of sulfonyl chloride. So to keep in mind that total pressure at equilibrium is not equal to Kp expression. Okay, now look at the question. Calculate partial pressure at equilibrium. So from the question, we only have initial pressure. So means that we cannot substitute the value of the pressure into the Kp expression directly. Then we need to use ice table. So we have another characteristic to support us to use ice table. Okay. Question B, look for the degree of dissociation. So formula for degree of dissociation is change over initial. So again, we have support us to use ice table to solve this problem. Now, look at the third example. An amount of 0.2 mole of sulfonyl chloride was placed. Again, was placed means that you just put into this container. So this also show information which is initial and allowed to reach equilibrium. Calculate the equilibrium constant. For the reaction, if the concentration of chlorine is 0.08, you are given concentration at equilibrium, but you are not given all the species because at equilibrium we still have sulfonyl chloride, we still have sulfur dioxide, and then we also have chlorine. But in this question now, we only have concentration for chlorine. So means that you have to find out what is the concentration of sulfonyl chloride at equilibrium. Because of this, you need to use ice table. Okay, we already finished 5 types of calculation. Do you think it is very easy to identify? Okay, I have introduced with you 5 types of calculation question. So now here we have 11 questions, but I only will discuss one question with you. The rest of the 10 questions, you are going to do it yourself. So please write down like this. What is the method that we use? For example, this question is the 4th method. So you write down 4 on the paper. The answer will be appear in the last slide. Okay, so look at this question, why we need to choose the 4th type. Mole for CO2, CF4, COF2 are given. All the species are here. And then you are given the Kc value, and then the question is asked us to look for the direction. So basically have these 2 criteria, all species, information for all species are given, and then they ask for the direction. Even though the question is not ask us to, is it at equilibrium? So basically we already know lah, it is not at equilibrium because they already asked us the direction. So we need to compare Q with K. Refer to the video in front, the slide in front. We know this is the 4th type that I introduced to you. So the answer is 4 here. Congratulations, you are in the last slide at where you need to check your answer. I believe most of you can get most of the answer correctly. So it's great that you can identify the type of calculation method that you are going to use. For your information, when we want to solve a problem, we must know the problem well. So if you know the problem well, means that you are on the halfway in successful. So hope you get the idea from this video and learn something. If you have any question in the calculation working step, you can refer to your lecturers or you can comment at the bottom, then we try to discuss together. Thank you.